Hey everyone! Did you know that the moon, the celestial body we've been gazing at for centuries, is older than we ever imagined? Groundbreaking research has just revealed its fiery origins, and it's turning everything we thought we knew about our lunar companion upside down. Today, we're diving into the stunning findings, unraveling the moon's fascinating story from its formation to the insights it provides about Earth and beyond. Stick around. It's going to be a wild ride through time and space. For decades, scientists estimated the moon to be about 4.5 billion years old, forming shortly after Earth. However, recent studies have pushed its age back even further. A groundbreaking analysis of lunar rock samples brought back by the Apollo missions shows evidence of a violent collision that occurred 4.53 billion years ago, a mere 50 million years after the solar system's birth. This makes the moon one of the oldest known objects in our cosmic neighborhood. But how did scientists uncover this ancient timeline? The answer lies in isotopic, dating a technique that measures the decay of elements, like uranium, to determine the age of the rocks. These findings not only redefine the moon's age, but also reshape our understanding of the early solar system. The moon wasn't always the serene, cratered orb we see today. Its origins are fiery and chaotic. Scientists believe the moon was born from a cataclysmic collision between Earth and a Mars-sized protoplanet called Theia. This massive impact ejected debris into orbit around Earth, which eventually coalesced into the moon. The early moon was a molten, glowing sphere of magma. Over millions of years, it cooled, solidified, and developed the distinctive surface we recognize now. The fiery start of the moon provides clues about Earth's own turbulent history, including how the collision may have shaped our planet's tilt, its seasons, and even the conditions that made life possible. Let's talk about the fascinating clues hidden in lunar rocks. The Apollo missions gave us a treasure trove of samples that scientists are still analyzing today. Recent research focused on zircon crystals found in these rocks, some of the oldest minerals in the solar system. These tiny crystals reveal details about the moon's magma ocean phase and how it cooled over time. What's more, they hint at how quickly the moon formed after the Earth-Theia collision. These insights are key to piecing together the solar system's chaotic early days, showing how planets and moons evolved from cosmic debris into the stable worlds we see now. Why should we care about the moon's age? Well, understanding the moon's history gives us a window into the early Earth. The same impact that formed the moon likely affected Earth's composition and even played a role in the development of its atmosphere and oceans. By studying the moon, we're learning about our own planet's origins and the conditions that made it habitable. It also helps scientists refine models of how planetary systems form, not just in our solar system, but around other stars. The moon is like a time capsule, preserving clues about a time when the solar system was young, violent, and full of possibility. The story doesn't end here. With upcoming lunar missions like NASA's Artemis program, we're poised to uncover even more secrets about the moon. New technologies will allow us to explore regions never visited before, like the moon's south pole, where scientists believe water ice exists. These missions aim to collect fresh samples, study the moon's resources, and even pave the way for a permanent human presence. Who knows what other revelations await us? One thing's for sure, the moon will continue to inspire awe, curiosity, and scientific breakthroughs for generations to come. The moon isn't just a distant observer in the sky, it plays a vital role in life on Earth. Its gravitational pull creates tides, which have shaped ecosystems for billions of years. The tidal forces also influence the rotation of our planet, gradually slowing Earth's spin over time. This interplay between Earth and the moon stabilizes our planet's axial tilt, preventing extreme climate swings. Without the moon, life as we know it might not have developed. Its influence is a constant reminder of the deep connections between celestial bodies and life on Earth. The moon's origin story revolves around Theia, a Mars-sized protoplanet that collided with Earth. But what happened to Theia after the collision? Scientists speculate that its remains were absorbed into the Earth and the Moon. This theory is supported by similarities in the isotopic compositions of Earth and Moon rocks. While Theia itself may be long gone, its legacy lives on in the Moon and in the story of how our planet came to be. The Moon's surface is dotted with craters, each telling a story of a cosmic collision. These craters were formed by asteroids and comets striking the Moon over billions of years. Because the Moon lacks an atmosphere, erosion, or tectonic activity, these craters remain preserved, offering a timeline of solar system events. By studying them, scientists can understand the frequency and scale of impacts, providing insights into the dangers faced by Earth in its early history. The Moon isn't entirely lifeless. It once had volcanic activity. Billions of years ago, magma flowed across the lunar surface, creating vast plains known as maria, or seas. These dark regions are visible from Earth and have been studied extensively. Lunar volcanism reveals clues about the Moon's interior and how it cooled over time. Understanding this activity helps scientists compare the Moon to other celestial bodies with volcanic histories, like Mars and Io, one of Jupiter's moons. The side of the Moon we can't see from Earth, often called the far side, remained a mystery until space probes captured its images. Unlike the familiar near side, the far side has fewer maria and is heavily cratered. The differences between the two sides have puzzled scientists for decades. One theory suggests that tidal interactions with Earth caused the near side to cool more slowly, resulting in the formation of maria. Exploring the far side could provide further insights into the Moon's asymmetric history. Recent discoveries of water ice on the Moon's surface have revolutionized our understanding of its potential. Water ice exists in permanently shadowed craters near the poles, where temperatures remain extremely cold. This resource could be vital for future lunar exploration, serving as a source of drinking water, breathable oxygen, and even rocket fuel. The presence of water on the Moon also raises questions about how it arrived there. Was it delivered by comets or generated through chemical reactions? The Moon's surface is covered in a fine, powdery soil called regolith. This material is the result of billions of years of meteorite impacts breaking down rocks. Regolith contains valuable minerals like titanium and helium-3, a potential fuel for nuclear fusion. Analyzing lunar soil not only helps us understand the Moon's history, but also provides resources that could support future space missions. Did you know the Moon once had a magnetic field? Scientists have found evidence of magnetism in ancient lunar rocks, suggesting the Moon's core was once active. This magnetic field likely protected the young Moon's surface from solar radiation, much like Earth's magnetic field does today. Understanding why the Moon's core cooled and its magnetic field disappeared could offer clues about planetary evolution. Solar and lunar eclipses are some of the most awe-inspiring phenomena in astronomy. The Moon's size and distance from Earth make it appear almost identical in size to the Sun, creating perfect solar eclipses. These events provide opportunities for scientists to study the Sun's corona and test theories about celestial mechanics. The Moon's unique position makes these spectacles possible, highlighting its importance in both science and culture. The Moon has inspired myths, art, and literature throughout human history. From ancient lunar calendars to stories of werewolves and moon gods, its cultural impact is immense. In modern times, the Moon continues to inspire artists, scientists, and dreamers. Its timeless beauty and mystery remind us of humanity's quest to understand the universe. The Moon was humanity's first step into space exploration. The Apollo missions not only landed humans on the Moon, but also laid the foundation for future exploration. Today, missions like Artemis aim to establish a sustainable presence on the Moon, setting the stage for journeys to Mars and beyond. The Moon remains a crucial stepping stone for our spacefaring ambitions. The Moon experiences seismic activity known as moonquakes. These quakes are caused by tidal stresses from Earth's gravitational pull, as well as the cooling and shrinking of the Moon's interior. Studying moonquakes helps scientists understand the moon's structure and composition, providing a glimpse into its dynamic interior. While the moon doesn't have a thick atmosphere like Earth, it does have a tenuous layer of particles called an exosphere. This exosphere is composed of elements like helium, argon, and neon. Studying it helps scientists learn about how celestial bodies without atmospheres interact with solar wind and micrometeoroids. Beneath the moon's surface lie lava tubes, natural tunnels formed by ancient volcanic activity. These caves could provide shelter for future lunar explorers, protecting them from radiation, micrometeoroids, and extreme temperatures. Exploring these caves could also reveal untouched geological features, offering a deeper understanding of the moon's history. As humanity looks to the stars, the moon remains our closest and most accessible destination. Its resources, strategic position, and scientific value make it a critical focus for space agencies and private companies. The moon is not just a relic of the past, it's a key to our future, unlocking possibilities for exploration, discovery, and survival beyond Earth. For millennia, humans have used the moon to track time. Its phases provided the foundation for lunar calendars, which were essential for agriculture and religious observances. Even today, the moon's orbit influences the way we measure months and seasons. Understanding its predictable cycle has shaped how civilizations developed, demonstrating the deep connection between the moon and human history. Have you ever wondered why we always see the same side of the moon? This phenomenon is called tidal locking, and it's the result of gravitational interactions between the Earth and Moon. Over millions of years, these forces slowed the moon's rotation to match its orbital period around Earth. This locking effect offers a fascinating glimpse into the dynamics of celestial mechanics and the long-term interactions between planetary bodies. The moon may hold secrets about life beyond Earth. Its surface has preserved ancient solar and cosmic particles, which could provide insights into the conditions that existed when life first emerged on our planet. Additionally, studying the moon's geology and resources could help scientists prepare for missions to other planets, where the search for life continues. The moon's far side is one of the quietest places in the solar system, shielded from Earth's radio interference. This makes it an ideal location for radio telescopes and astronomical observatories. Building a telescope on the moon could allow scientists to explore the universe's earliest moments, detecting signals that are invisible from Earth's surface. As we prepare for missions to Mars, the moon is an essential testing ground. Its proximity allows astronauts to practice long-duration space travel, resource utilization, and survival in extreme environments. Technologies developed for lunar exploration, such as habitats and rovers, will be critical for future missions to the Red Planet. Lunar swirls are strange, light-colored patterns found on the moon's surface. These formations have baffled scientists for years. Recent studies suggest they may be linked to magnetic anomalies caused by ancient asteroid impacts. By understanding these enigmatic features, scientists hope to learn more about the moon's magnetic history and the processes that shaped its surface. The moon is a treasure trove of untapped resources, from rare metals like titanium to helium-3, a potential energy source for fusion reactors. The moon offers materials that could revolutionize industries on Earth. Mining the moon responsibly could open new frontiers in science and technology, fostering sustainable development both on Earth and in space. Lunar dust, or regolith, is more than just a nuisance. It's a serious challenge for astronauts and equipment. Its fine, abrasive particles can damage machinery, clog filters, and even pose health risks if inhaled. Engineers are working on innovative solutions to mitigate the effects of lunar dust, ensuring safer and more efficient exploration in the future. From classic films like 2001, A Space Odyssey, to songs like Fly Me to the Moon, our fascination with the moon is deeply embedded in popular culture. It has inspired countless works of art, literature, and music, serving as a symbol of mystery, romance, and human ambition. The moon's presence in our collective imagination continues to fuel creativity across the globe. The moon's phases have long been associated with human behavior, from myths about lunacy to beliefs in its impact on sleep and mood. While science has debunked many of these ideas, the moon's cultural and psychological significance remains strong. Its consistent cycle offers a sense of connection to the natural world, influencing how we perceive time and change. The moon indirectly affects Earth's climate through its gravitational pull, which impacts ocean currents and tides. These forces play a role in distributing heat across the planet, influencing weather patterns and ecosystems. By studying the moon's interactions with Earth, scientists can gain a deeper understanding of our planet's climate system. The Apollo missions and ongoing lunar exploration efforts have inspired generations of scientists, engineers, and astronauts. The moon serves as a symbol of what humanity can achieve through curiosity and innovation. The moon serves as a platform for fostering international cooperation and peace in space. Establishing a permanent presence on the moon is a crucial step toward living on other planets. Lunar bases will allow scientists to test technologies for sustainable living, such as harvesting water, generating power, and growing food. These experiments will provide valuable insights for building settlements on Mars and beyond. The Earth via collision that formed the moon offers a unique case study in planetary impacts. By studying the moon's composition and structure, scientists can learn about the effects of such collisions on planetary systems. This knowledge helps us understand the formation of exoplanets and the conditions that lead to habitable worlds. The moon is the next frontier for space tourism. Private companies are already planning missions to send civilians to orbit or even land on the lunar surface. These ventures could transform how we experience space, making the dream of visiting the moon a reality for more people. Growing food on the moon is no longer science fiction. Researchers are experimenting with hydroponic and aeroponic systems to cultivate crops in space. Successful lunar agriculture could provide fresh food for astronauts and pave the way for sustainable living on other planets. The moon acts as a natural shield, absorbing impacts from asteroids and comets that might otherwise strike Earth. Its craters are a testament to this protective role. Understanding the moon's impact history helps scientists develop strategies for planetary defense, ensuring Earth's safety from future threats. The moon could play a role in advancing quantum technologies. Researchers are exploring the possibility of using the moon as a base for quantum communication networks, which rely on entangled particles to transmit information securely. These advancements could revolutionize fields like cryptography and computing. Above all, the moon is a constant presence in our lives, a silent witness to the passage of time. Its cycles connect us to ancient traditions and future possibilities. As we continue to explore its mysteries, the moon will remain a source of wonder, inspiring humanity to reach for the stars. The moon influences the behavior of many animals. For instance, sea turtles rely on moonlight to navigate during nesting, while certain fish species synchronize their spawning with lunar cycles. Even nocturnal predators and prey adjust their activity based on the moon's brightness. Understanding these connections helps ecologists study how natural rhythms shape ecosystems. The dark regions of the moon, known as Maria, are ancient lava plains that formed when volcanic activity flooded large basins billions of years ago. These plains provide clues about the moon's internal composition and its cooling process. Studying these features also helps us compare volcanic activity across other planets and moons, like Mars and Io. The moon is like a geological time capsule, preserving evidence of Earth's earliest days. By studying the moon's composition and its similarities to Earth's mantle, scientists can refine theories about how our planet formed. These insights contribute to understanding how other rocky planets in the universe may have developed. The moon's surface has been bombarded by cosmic rays for billions of years, creating a natural archive of space weather. By analyzing how these rays interact with lunar soil, scientists can better understand cosmic radiation, which is essential for protecting astronauts during long-term space missions. The Moon's stable environment makes it an intriguing location for experiments seeking to detect dark matter. Scientists are exploring the idea of using lunar instruments to study particles and forces that could reveal the nature of this elusive substance. The Moon could become a key site for unraveling one of physics' greatest mysteries. Throughout history, the Moon has been a symbol of femininity in many cultures. Today, it represents progress and inclusion as more women lead space exploration efforts. ENASA's Artemis program, named after Apollo's twin sister in Greek mythology, highlights this shift, with women taking on key roles in lunar missions and leadership. The Moon's gravity is about 1/6 that of Earth's, which significantly impacts how objects move and behave on its surface. This low gravity poses challenges and opportunities for exploration, from designing spacecraft to testing how humans adapt to reduced gravitational forces. Studying these effects prepares us for missions to planets with similar conditions. Rovers like China's Yutu-2 and NASA's upcoming VIPER mission are revolutionizing our understanding of the Moon. These robots explore areas humans cannot reach, such as permanently shadowed craters. Their findings help scientists map resources, study geology, and pave the way for future manned missions. The Moon has inspired countless tales, poems, and paintings. From ancient folklore to modern science fiction, it has been a muse for artists and writers worldwide. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.